Hello everyone, this is Siddharth here. Today we'll be discussing Path Sum 2, today's LeetCode daily challenge problem. We are given the root of a binary tree and an integer target sum. What we need to do is we need to return root to leaf paths, all such paths where the sum of all the node values in our given path equate to the target sum. So let's take an example. So in this example, we have a binary tree with a root value of 5 and a target sum of 12. We have a temporary sum array in which we'll be pushing back all the values that come in our path. Also, we have a resultant array which consists of all such arrays which have the sum of all the node values in a path which are equal to our target sum. So at very first, a pointer will be pointing to our root node. We'll check if it's not pointing to null. If it's not pointing to null, then we'll push back that node's value into our temporary array. So we'll push back 5 in it. Now we'll see if this is a leaf node or not. We'll see if the node that our pointer is pointing to is a leaf node or not. If that's not a leaf node, then what we'll do is we'll move to its left child. We are following the pre-ordered traversal here. Also, while going to its left child, we'll see if our pointer now is not pointing to null. If that's so, then we'll push back this very node's value into our temporary array. Now we'll move to its left child and we'll see if now our pointer is not pointing towards a null, then we'll push back this very node's value as well. Also, we'll be checking if all these nodes are leaf nodes or not. So how one can check that if the pointer is pointing towards a node that is leaf or not? We will know if that very node has no left and right child. So since our root here had a left child and a right child as well, that's why this is not a leaf node. We came to 4 and then we also saw that it has left and right child, so it's not a leaf node. But after coming to this very node that has the value 2, we see that this has no left and right child. So this is a leaf node. So after encountering a leaf node, what we need to check is we need to check if the sum of all the values in our temporary array equate to our target sum or not. If it's so, then we'll have this very temporary array pushed to our resultant array. And if that's not the case, then we'll backtrack from here and we'll remove all the subsequent values that we'll be passing from. So since 5, 4 and 2 when added together do not equate to 12, what we'll do is we'll backtrack from here and we'll be removing 2 from our temporary array. We see that 4 has right child, so we'll be going to that very child. We'll see if our pointer is pointing towards a node that is not null. So what we'll do is we'll be pushing its value into our temporary array, and now we'll see if 3 is a leaf node or not. Since it is a leaf node, it has no left and right child. So now we'll check if the sum of all the values in our array equate to 12 or not. Since we know that 5, 4 and 3 when added together equate to 12, what we'll do is we'll push back this array into our resultant array. Now after doing that, we'll be backtracking from here. So we'll be moving back to our parent node 4 and we'll be removing 4 from our temporary array as well as 3. So we'll be backtracking back to 5 and then we'll see if this has a right node or not, right child or not. After checking that this has a right child, we'll see that this is not pointing towards null. and then we'll be pushing back its value into our temporary array. So after checking if 7 is a leaf node or not, since it's not, we'll be moving towards its left child. Now we'll be pushing back its value into our temporary array. Since this very node is a leaf node, what we'll do is we'll check now if the current sum of all the values in our temporary array equates to 12 or not. Since it does, we'll be pushing back this very array into our resultant array as well. Now we'll be moving back to see if this very node 7 has any right child or not. Since it does not, then we'll just go back and our traversal will end here. So to clear that up, we'll have a resultant array which will consist of two such arrays. This will be our answer for that given example. So now let's code it up. I'll be creating another function for our traversal. We'll be passing the root and the target sum value to it. First of all, we need to check if our pointer is not pointing towards null. Since if it will be pointing towards null, we'll just return from here. Now what we need to do is we need to have a temporary array that will contain all the values in our path. So we can declare an array here. We also need another array which will be our final result. We'll also be needing a temporary sum variable which will be taking care of the sum of all such values. So what we need to do is, after checking if our given pointer is not pointing towards null, what we need to do is we need to push the value of our node into our temporary array. After doing that, what we need to do is we need to check if the given node is a leaf node. How do we check that? We can check that by writing if there is no left child to our root and there is no right child to our node. We also need to check if the given sum, the given temporary sum, is equal to our target sum. We can do that by writing this. So if that's the case, then what we need to do is we just need to push back this very temporary array into our final array, in this case a vector. So if that's not the case, what we need to do is we'll just call our same function for our left child, and then we'll call it for our right child. After doing that, we need to backtrack. Since we are backtracking, I'll be needing to remove my latest node values from my temporary array. I can do that by I forgot about taking care of our sum. So sum will be taking care of our current total sum of our temporary array. since we are removing those specific values from our temporary array, we also need to remove those from our sum. And we just need to call our function here. Let's see if this is running well. As you can see, this is running perfectly fine and it's also pretty efficient. So I hope you liked the video and you understood everything that we talked about today. And if you did, please like and subscribe. If you did not, then I'd love to hear from you. Please let me know as to how I can do a bit better in this, and catch you in the next one.